So next question is, an electric iron resistance 20 ohm takes a current of 5 amps. Calculate the heat developed in 30 seconds. So what he has given resistance he has given, that means R is equal to 20 ohm, and amp, that means I is equal to 5 amps. So and T is given, T is equal to 30 seconds, and he is asking H is question mark, heat developed. So H is equal to question mark. So we know that formula H is equal to I square R into T. So I is given 5 square into R is given 20 and T is given 30 seconds. So if you simplify this, you will get 15,000 joules. So if you shift the point to here, you will get 1.5 into 10 to the power of 4 joule. So the heat developed in 30 seconds, H is equal to 1.5 into 10 to the power of 4 joule. So practical applications of heating effect. So again same heating effect. Heating effect means we are passing current through a resistance. Part of current is used for lighting or our purposes, our aim, and remaining part of energy used for heating. This heating effect, is there any practical applications is there? That we will see. So many applications are there. Okay. Electric laundry, that means iron, electric toaster, electric oven, electric kettle, electric heater. Okay, these are all the familiar devices. And also, see, producing light. So houses we are using now. So that is light, and it emits light. Okay, and these fuses also due to the heating effect. Okay, so full detail we will see. The generation of heat in a conductor is an inevitable consequence of electric current. Okay, it is undesirable as it converts useful electric energy into heat. So actually it is a useful electric energy, but it converts into heat. So in electric circuits, the unavoidable heating can increase the temperature of the components and alter their properties. However, heating effect of electric current has many useful applications. I told you, same. So electric heating is also used as a produce light. So as in the electric bulb, here the filament must retain as much as of the heat generated as is possible, so that it gets very hot and emits light. Some portion of electric energy converted into light, and some portion will get the filament to get hot. So it must not melt at such high temperatures. So a strong metal with high melting point such as tungsten, this may ask in examination. Melting point 3380 degree centigrade is used for making bulb filaments. So the filament should be thermally isolated as much as possible. So using insulated support etc. The bulbs are usually filled with chemically inactive nitrogen gas or argon gas. So the bulbs may be filled with a inactive nitrogen gas or argon gas. So to prolong the life of the filament, they have used the filament. To protect this filament, they have used the inactive nitrogen or argon gases to increase the lifespan of this filament. Okay. Most of the power consumed by the filaments appears as heat, but a small part of it is in the form of light. Actually, we want light, but part of that current energy is converted into heat energy. Okay. So next, another common application of the Joule's heating is the fuse. Already I told, used to electric circuits. So inside your houses, so one board will be there. There you can see the fuse. It protects circuits and appliances by stopping the flow of any unduly high electric current. So that fuse is placed in series with the device. So it consists of a piece of wire made of a metal or alloy of appropriate melting point. Okay, that piece of wire is there now. That piece of wire having appropriate melting point. For example, aluminum, copper, iron, lead, etc. If a current larger than the specified value flows through the circuit, the temperature of the fuse wire increases. So this melts the fuse wire and breaks the circuit. This is very, very important. So the fuse wire is usually encased in a cartridge of porcelain or similar material with the metal ends. The fuses used for domestic purpose are rated. If you see the fuses, they will write on 1 amp, 2 amp, 3 amp, 5 amp, 10 amp like that. Okay. For electric iron, which consumes 1 kilowatt. So for electric iron box, it requires 1 kilowatt power when operated at 220 volt. A current of 1000 divided by 120 amp, that is 4.54. So if you are using 4.54 amps, our fuse should be greater than 5 amps. So we will flow the current. In case of in this case, so we need 4.54 amps. Okay, but for that we have to use greater than 5 amps fuse. So that is our condition. So if this is the case, we have to use greater than 5 amp fuse. This is our requirement.